Hello everyone, welcome to my channel on learning field. Today in this topic I will teach you how to derive the formula for electric field due to an infinite charged plane. So first of all, we need to draw a diagram relating to this topic. Let us draw the diagram of charged planes. We have drawn the diagram for infinite charged plane. So first of all, we need to consider that consideration part. Consider an infinite plane sheet of charged with surface charge density sigma. We have considered that surface charge density sigma with surface charge density sigma. Let P be let P be a point at a distance r. Let P be a point at a distance r. From the sheet, and E be the electric dipole moment, and E be the electric dipole moment at P. Now we have seen that there is a positive charge plus. We have already seen. Since we need to consider an infinite charge plane, that is why we have drawn a surface charge density. We have considered surface charge density sigma and drawn a plane sheet. Now we need to considered a Gaussian surface in the form of a cylinder. We have considered a Gaussian surface in the form of a cylinder. Since it's look like a cylinder, of cross sectional area A. Okay. And length twice r, perpendicular to the sheet of the charge. We have considered a Gaussian surface in the form of a cylinder. We have considered a Gaussian surface in the form of cylinder of cross sectional area A, and let the distance between them be twice r, perpendicular to the sheet of the plane. It is perpendicular, isn't it? It is perpendicular to the plane sheet of the plane of charge. Since the plane sheet contains a charge, we have considered a perpendicular surface on the plane sheet, this Gaussian surface in the form of cylinder. of cross sectional area A and length twice r perpendicular to the seat of charge. Therefore, we can write, therefore the total flux through the closed surface is given by phi is equals to, now therefore the total flux through the closed surface, since we know the formula flux, if we remind the formula flux, phi is equals to electric field into A, that is area. This is the formula of electric flux. This formula you need to remember and apply in every derivation, since we know that electric flux phi is equals to electric field into area. Now we have considered a total flux through the surface, so we can write phi is equals to integration, since go slow deals with the closed surface, therefore we need to write close integration of electric field into ds, since we have considered a small amount of area, that is ds, that is why we need to write close integration of eds. This is the point P, plus this is for one surface, and for another surface it will be close integration of eds of dipole moment P. Now look here, this is in vector quantity, isn't it? This is in vector quantity. Now to remove, if you'll remove this vector sign, what will be the, what will it will take up the, we need to write sine theta, or you can write cos theta. In this problem we need to consider cos theta. Okay, so it will be close integration of eds. If we remove the vector sign, then we need to write angles, eds cos theta, plus close integration of eds cos theta, this point P of dipole moment, point P. Now phi will be equals to close integration of eds, because since in the plane sheet theta is equals to, because we can write afterwards eds and close integration of eds, this point P. Since theta is equals to 0 degree, then cos theta will be equals to 1, isn't it? Since it is parallel, and since the line is perpendicular, if perpendicular, then theta is equals to 0 degree, then cos theta is equals to 1. Since we have considered a plane sheet, that is why theta is equals to 0 degree and cos theta is equals to 1. Now it will be, now close integration of eds, this electric field will come out, since it is constant quantity, so integration of ds will be equals to integration of ds, sorry, here plus sign should be there, integration of ds plus integration of again ds, it will be integration of ds, since we know that if we consider the integration of ds, then it will be a electric field A, plus close integration of ds will be E into A. Now this and this are same, we can consider twice EA. If sigma is the charge density, per unit area in the plane sheet, then the then the net positive charge q within the Gaussian surface is. Now look here, if sigma is the charge density, since in the consideration part we have considered a, let us consider sigma be a charge density of surface charge density, isn't it? So if sigma is the charge per unit area in the plane sheet, charge per unit area means if sigma is equals to q by a, if sigma is equals to q by a, charge per unit area means q by a. So in the plane sheet, then the net positive charge, if net means what, the that means it resultant, net means resultant, net positive charge q within the Gaussian surface is, now q will be equals to, if we cross multiply this one, q will be equals to sigma into a. So now substituting the value of q here, since we know that q is equals to what, q is equals to, since in the formula we have learned that by applying the Gauss law, we know that by applying Gauss law, we know that since we have studied Gauss law, phi is equals to q by epsilon naught. This is the expression for Gauss law, isn't it? Now substituting the values here, we came to know that phi we have already done, phi is equals to this much, phi is equals to twice of electric field into area, we have already shown here, isn't it? Now substituting the values here, it will be twice E into A, which is equals to Q. Since Q is equals to sigma into A, we can substitute here, isn't it? So sigma into A, epsilon naught will be same here, so it will be like that. Now if we cross multiply this one, it will be, look here, how to cross multiply this one, let E be in one side and twice A be in one side, then it will be sigma by A. Now A cancel, epsilon naught, again this E will remain here, since we need to find the electric field expression, so E will be here, then this 2 will be cross multiplied, sigma by epsilon naught 2. So this is the required expression we can write here. This is the rough work you need to note down. So it will be, electric field will be equals to sigma by twice of epsilon naught. This is the required expression we need to prove in this derivation, hence derived. Now our next topic is proof. The question may come, proof Gauss law. Now how to prove Gauss law? If you think, first of all, since physics is all about diagrams and formulas, so first of all draw the diagram. Suppose this is a closed surface of radius, let radius be r, okay, and charge be q, and let the radius be r and charge be q, okay, electric field E, and the distance, let us consider a small area ds, okay, Then we came to know that this is the expression of phi. Okay, phi. Then we came to know that since phi of EDS, which is equals to phi of E, which is equals to q by epsilon naught. Since we know that Gauss law states that phi is equals to q by epsilon naught, isn't it? And we know that integration of phi EDS equals to phi E, and phi E is equals to q by epsilon naught. Again we know that this is expression 1, this is expression 2. Electric field of R will be equals to 1 by 4 pi epsilon naught into q by R square. By knowing these two, we can easily prove this Gauss law. Now taking the left hand side, that is EDS, phi of EDS, which is equals to, now close integration. Since we are dealing with the closed surface, so it will be close integration of 1 by 4 pi epsilon naught into q by r square into ds. Okay. Now close integration of 1 by 4 pi epsilon q by r square ds. Now first of all we need to take out the constants. So 1 by 4 pi epsilon naught into q by r q, isn't it? Now what will remain here? Only ds will remain here. All will be constant quantity to r square into close integration of ds. Since close integration of ds will be 1 2 3 4, it will be q by 4 pi epsilon naught into r square. It will be 4 of 4 pi of r square. Since we know that circumference of a circle is equals to 2r, and here how many electric fields are there? 4 electric fields. So 1 2 3 4, so 4 pi r square. So it will be q by epsilon naught. How? If we cut this one, if we cut